All right, we're going to go ahead and kick off Module 4 here, dealing with the topics in Chapter 3. A little bit of background on how Chapter 3 is going to work. It's going to be split into roughly two halves. The first half is going to deal with solving triangles and finding their area through what are known as the law of sines and the law of cosines. The second half, which is actually going to take up probably about 2/3 of this particular module, is going to be dealing with some ideas involving vectors. The idea being that these are directed distances, and they have a lot of new ideas, operations, and other pieces that we're going to investigate as they relate to trigonometry and as they're going to affect you going forward. But to get things started, we're going to go ahead and go back to familiar territory, dealing with triangles and some of the trigonometric functions that we've already dealt with. Here in section 3.1, that means talking about the law of sines. So to give you a little bit of an idea of the objectives, we're going to be using law of sines in this section to solve oblique triangles. We'll talk about what that means here in a moment. These are ones that are in the AAS or ASA formats. That A stands for angle, side for S. So these would be angle-angle-side triangles, angle-side-angle triangles, and this is denoting what information we already know about the triangle as we attempt to solve it. We're also going to be looking at a special type of oblique triangle, one where we know two side lengths and one angle, what we call an SSA triangle. These ones are going to involve a little bit of extra work because they actually kind of branch off into a variety of different cases. We're also going to be looking at finding the areas of oblique triangles. This will be a little bit more difficult than our standard area formula, simply because the triangles that we're dealing with are going to have a little bit of a struggle when it comes to measuring their altitudes. And then the last thing that we're going to take a look at is using the law of sines to model and solve real-life problems. Section 3.1 is going to be split up into a couple parts here. We're going to focus on the first objective with this lecture and kind of touch a little bit on how we're going to do the second bullet point. We'll see an example and some broad strokes, but then we'll revisit it with some more work in the next lecture. To go ahead and kick things off, let's go ahead and see a basic introduction to the ideas we're talking about. Because I keep talking about oblique triangles, in solving them, it would be helpful if I talked about what that actually means in this context. So when we talk about oblique triangles, these are triangles that have no right angles. This is actually kind of a huge bummer for us because it means that our trigonometric functions don't automatically apply. Remember that our trigonometric functions are defined when we're dealing with right triangles. When I talk about the sine of an angle in oblique triangle, it cannot be defined as the opposite over the hypotenuse the way we would normally, because since we're an oblique triangle, there is no such thing as a hypotenuse. So we're going to have to rework our ideas if we're going to use our trigonometric functions. It doesn't mean they're useless, it just means that they're going to have to be used in a slightly different way to find slightly different ideas. One thing to note here, because we're not dealing with right triangles, it's very important to pay close attention to our labels as we're dealing with these. We can't just say, oh, that's the right angle, or oh, that's the hypotenuse, and treat them as such. In this case, each angle and each side are going to be special, and their information is going to be important as we go forward. Remember our naming convention, by the way. Our angles are going to be labeled with capital letters, and our sides are going to be lowercase letters, specifically the same letter as the angle for the side opposite. You can actually see that right over here. Angle A, the side opposite, lowercase a. Angle C, the side opposite, is lowercase c, and so on. Now to the idea of solving triangles. What does it mean to solve an oblique triangle? Well, the idea first and foremost is that you need to have enough information for it to even be possible. You have to know the measure of at least one side and any two other measures of the triangle. This is actually something that you would have dealt with back in high school geometry when we talk about the different rules for congruent and similar triangles. When we talk about all the different congruence measures and ideas that we have, notice that almost all of them use at least one side, in some cases two, and in some cases three, to completely say, hey, it's congruent to another triangle. We're working under the same constraints. So these are the ideas. We need to know at least one side and then any two other measures. We could know two sides, which would give us quite a bit of information. We could know two angles in addition to the side, which actually gives us more because of some ideas we'll talk about in a moment. Or we could know one angle and one side, and that one can lead us into a little bit of difficulty depending upon which angle it is that we know. But the idea here is that these are the basic parameters for what we need in order to be able to solve an oblique triangle in the first place. If we don't have this information, then basically we have to shrug our shoulders and say, I can't solve this. There's nothing I can do. But based on what information we get, there's going to be 4 rough scenarios on what can happen next. Let's say that we know a side length and we know 2 angles. This is one of the cases that we were talking about. Then based upon that information, you are either dealing with an angle-angle side or an angle-side angle situation. You should recall that in this case, since we're dealing with a triangle, if we know 2 angles, we can always solve to find the measure of the third angle. So this one actually gives us a wealth of information, and it's usually the best case scenario for us. A second case, let's say that we know an initial side, but then we know one other side and another angle. The thing here is the angle that we know is going to be opposite one of our known sides. Another way to say this is that the angle we know is excluded. It's not between the 2 sides that we know. This is the ambiguous case that we're going to spend a lot of time with both in this lecture and in the next one, because it leads to its own separate breakdown of what's possible. The last cases are, let's say we know one side and 2 additional side lengths. In this case, we can actually use that pretty powerfully to solve for the remaining angles, so long as we have the appropriate formula. And the last case is, let's say that we know a side and again an additional side and angle, but this time the angle that I know is actually going to be included between the 2 known side lengths. This one is going to follow quite nicely to find the third side, and then from there we can play around to find one angle, and then use the properties of triangles to find the third angle. But it's important to note that both cases 3 and 4 are going to be something that we deal with in a later section. Here in section 3.1, cases 1 and 2 are going to be solved using what we call the law of sines. The last 2 cases, 3 and 4, require what's known as the law of cosines. Basically, this is what happens when we have 2 sides and an angle known, or 3 sides known. It's going to challenge a little bit how we find the measure for the angles, unless we're in the ambiguous case 2. This is actually important information that you should actually copy down now, because it's going to be much more relevant as we go further and further into this chapter. One of the toughest things about the exam for this module is figuring out when you're supposed to use law of sines and when you're supposed to use law of cosines. So this particular breakdown here is an excellent way to go ahead and take that apart.